Hello everybody, my name is Aaron. Today I'm going to walk you through an example of a converted app that was originally written in MongoDB's Atlas Device SDK from Realm over to Couchbase Lite using app services in Couchbase Capella. This is a Maui application. Now this is the third video in a series of videos over the conversion process for .NET Maui developers. In the first video, we walked through how to set up Couchbase Capella and app endpoints with app services in order to sync information. In the previous video, or our second video, we went through and also demoed off the application, had it running in both iOS and Android, and showed off the differences in how sync works. And this video is a deep dive of the code that we changed as part of the conversion. So if you're a software developer and you want to understand why we made changes and how we made those changes, this video is for you. The video description has a link to all the various videos previously, and those should also be in the playlist. It has a link to the code repo. And if you don't have that link, it should be github.com/couchbase-labs/cbl-template-app-maui-to-do. You can grab the code from the code button over here or in the directions we go through, and also give you a link to how to download the code and using the git command. So with that, let's go ahead and get started with this conversion. Now, the first thing to show off is that we have a link to the original converted code right over here. It's this link right here. I have it open already in my right here. And this is the original version of the application. If we take a look here, it's got a Realm to-do folder. Inside the Realm to-do folder, it's got a normal shell application. And what I want to start talking about first of all is tech debt. Okay. Inside, when you start to think about changing out an application, you have to take a look at some of the tech that you have. We had to take on some additional tech debt that I wouldn't necessarily do. And you have to make some decisions. Should you do that tech debt and make sure your application works prior to converting to Couchbase Lite? Once you start the conversion process, it's my personal recommendation that all you do is the conversion process. You don't take on any other tech debt, because what's going to happen if you do that is you won't know why the application's busted if it doesn't work. You won't know, is it the change the Couchbase Lite that's causing the regression or the problem, or is it some other tech debt you're taking on at the same time? So one of the challenges is really trying to put a line in the sand and say, look, we're not going to make any more changes to this app until we have it up and running in Couchbase Lite. Now, when I downloaded this code and took a look at it, it had some problems. And some of the problems has to do with the fact that it's using .NET 7 and not .NET 8. Now, for most people, if you're not used to .NET Maui, you won't understand why that's a problem. And mostly this has to do with, this is not a long-term support, so LTS version. That's the first problem. We would like to get that on .NET Maui 8, which is LTS. But more important is that version doesn't support the latest version of Xcode 16, and the latest versions of the Android SDK. Okay, this is a locked in time because it's not long-term support. It's got limitations of what it's going to support for your compilers when you go through and build the applications, get them out to the App Store. We wanted to guarantee that this application could work for all .NET Maui developers, regardless of what tools they have installed their computer, at the least at the time of the recording of this video and when we converted the application. We know that .NET 8 is a long-term supported version, so we had to make the very hard decision to migrate this application first to .NET 8 and .NET Maui 8 in that latest version of workload. Okay, so we did that prior to making the Couchbase Lite conversion. Now, with that conversion, you also have to change out some of the things that this application uses, the NuGet packages, right? So you'll see here, it's using both the community toolkit for MVVM, model view model, and also it's using the community toolkit for Maui for things like components and stuff, right? So because of that, I had to upgrade both these NuGet packages also. So this is prior to me changing a single drop of Couchbase Lite code. So I'm going to go through and show you now let's compare these two, right? So to do that, I have another version of this. So let's bring this tab over here so we can see it. And then let's go ahead and bring our this solution file over here, our CS project file, so we can look at the differences and we can see that. So see here, this is what it looks like before. So before we are targeting .NET 7, right? So the very first change we made was to target .NET 8. So you see here, we're targeting Android, iOS, and Mac Catalyst. We also went through here and updated the NuGet package versions for both the Maui community toolkit, the 9.03, and to the MVVM version 8.32. So these are different than what you see here, right? So we made those changes in order to be compatible with .NET 8. Now, this adds on to a whole nother pain point that I do want to kind of cover, and this is covered in the document, but I do want to kind of go through and make it, call this out. So the Xcode 5.4 to 16 has caused some confusion in the community. So one, it has to do with Maui workloads. Okay, if you're a Maui developer, you need to understand this. If you're using Xcode 15.4, you only can use the Maui workload up to 8.0.402.0. This is the version that supports Xcode 15.4. If you're using Xcode 16 or later, you need to be using a workload version of 8.0.402.1. This is not me, this is Microsoft. This is covered, and I have a link to this posting here in a GitHub issue where this is explained by Microsoft employees, where people are complaining about it. It says that the target version is not working. And if we scroll down far enough in this list, you'll see here that this is a Microsoft employee. He's pretty famous. Gerald is on YouTube. He's on Twitter, all those different places. He'll tell you right here exactly what I kind of put in there, that Xcode 15, you have to use this version. And if you want to use Xcode 16, you have to use this version. And he kind of explains that there's nothing else they're going to do. That is just how it works. There's a big, long debate about this and that. You need to understand that this is not a problem within the repo. This is just how .NET Maui is working. So that's the very first thing I want to call out. Now, the second thing is that if you install both these versions, okay, so if you upgrade to this by accident and you have Xcode 15.4, you won't work because it won't know which one to use. This seems to be a common problem with another error that people are seeing, as this one, which is reported on the community toolkit repo. This is the same problem, okay? It's the Xcode 15 versus 16. So inside of .NET, there is something called a global JSON file. And this global JSON file basically gives you the ability to force the version of .NET Maui workload that you want to use, okay? And so what they're telling you is specifically is that if you are running Xcode 15 or 16, depending on that version, and depending on the version of Maui, you may need to make one of these global.json files, and you may need to specify which version you want to use so that it knows and it's not confused when you have multiple versions installed in your computer with Xcode. These are, once again, .NET Maui issues between Xcode 15.4 and Xcode 16. Now, you're probably saying, well, Aaron, why don't you just check in a global.json file? Well, I'm not going to do that because I don't know what version of Xcode you're using. And if I try to fix it for one, I'm going to break the other, right? And so the answer is, you just need to understand this as a .NET Maui developer. And if you are not running the latest version of Xcode and you have version 8.0.402.1 installed, you're not going to work. And this is going to be across the board, according to Microsoft's postings here on GitHub, unless you use one of those global.json files, which, once again, there is a link in this issue here to how to do that. I just want to get those off. This is technical debt, but this is just trying to get people working so that, obviously I want this code to be able to be used by the most amount of Maui developers out there. And I just don't know whether or not you're running Xcode 15.4 or 16. So I just want to get that off. If you're having those errors, go ahead and go into the README here and go through and read those postings, get your environment set up in a way that you can actually use this. Now, let's take a look at the overview of the application so we have an understanding of why certain things, other things had to be replaced. So inside here, we have this app flow. What's going to happen is this is a Maui application. So as a .NET Maui application, you know that .NET Maui applications are based on a Maui program. They make something called an app, and that is where .NET Maui's fingerprint is. Now, this is a shell application, so it's going to have an app shell. However, the problem is we want to guarantee that the login window comes out, and there's no way to get to the login window without the user logging out. And so because of that, that shell handles navigation, right? What we did is went through and made a change to guarantee that the login page is a security boundary, that there's no way for somebody to get access to a database until they actually physically provide a good username and password. We want to guarantee also that the navigation experience is pretty solid. The most popular way to handle this pattern in .NET Maui is to basically make the login page not part of shell. The login page is a standalone page. You make that as part of root. You validate in the business rules that your application can authenticate, and only when it can authenticate then do you then bring up the app shell that brings out the initializes your database, does all the syncing stuff, and actually gets the app up and running. So this flow explains that. So if you have not used this code base, I just want to explain to you that's how it works. So once I had the .NET 8 stuff solved, right? So I went through, got that working, got it compiling on my computer. And in the previous video, you saw me, everything works with debugging and stuff. Then the next thing I needed to do is to go through and get the Couchbase Lite working inside of the application. So what I'm going to go through here is show you in the solution file. The next very much thing I needed to do was to remove Realm and start the process of getting .NET Maui working. Okay, or get Couchbase Lite working. So what I did was I removed Realm right here. Okay, and then I added the Couchbase Lite SDK, and that was the very next thing. Now this is using community version. It's not using enterprise. I could have used enterprise, but for my sake of this demo, I didn't need encryption, and I didn't do Delta sync or Delta changes. So because of that, I can kind of get away with the Lite or the community version versus enterprise. If you're using those enterprise features, you'd want to go through and make this the enterprise version of Couchbase Lite's NuGet package. And all that's going to be available from the docs website, where you can go to docs.couchbase.com. And from here, you want to go to mobile. From mobile, you want to go to Couchbase Lite, and you want to go to .NET. And the installation process under start here and install, we'll go through and explain the differences between Couchbase Lite and enterprise. So depending on those, you need to go through and do that. Okay. So I'll make the assumption you know what version of Couchbase Lite. If you're using app services, that technically speaking, the license for app services gives you a license for Couchbase Lite Enterprise with Capella. So once I did that, obviously your application is going to break at that point in time, right? Because there's a lot of stuff going on here. So what is the order of precedence in order to once you do a conversion? So one, have to understand how Realm works in order to understand what you have to remove. Okay. So the first thing I removed was Foddy Weavers. Foddy Weavers is these two files here and small amount of configuration. And what this does is this allows Realm's SDK to work with Link. And we don't need that here. So you can see here, this has got a configuration for Realm, and it goes through and gives the ability to work within Link and how Link queries work and stuff. Those two files are needed, so I deleted those. And I made sure that there was no references to Foddy Weavers anywhere in NuGet packages, anywhere in the config files, just to make sure to guarantee that that was the case. So that's the very first thing I did. Now, the next thing I did was I got to explain the Realm flow here. So there's a couple things that I felt weren't properly .NET, and that's the Realm service here. So I'm in the Realm version of this application right now, and the Realm service is a singleton. It's basically a static class, which turns it kind of into a singleton. And you can see here, it's using things like the Realm SDK. So the app is used for authentication. Also for Realm, it's got to know the main thread, so it knows when to write onto the main thread when you're doing things like your subscription. It also links out to like current user, what's provided by the app, because the Realm app is what handles authentication. And so there's a bunch of different things that happen inside of this thing that one, an abstract class is really not, this doesn't make this all that testable, right? If you wanted to write this, and this is a real world application, this would probably be a real class, and then it would probably have an interface on it, and then you would have a mock version, and then obviously the implementation version. That's my recommendation on all this, right? So this is probably not the right pattern for it. On top of that, when we go into the main program, then none of this stuff gets loaded, and it just makes it super kind of flaky. Well, Maui fixes this. And in Maui, especially, you can load in services dynamically in the program. So a couple things of technical data is if I'm going to write a new service, because I need to write that, it's going to be a Couchbase Lite one, I would probably write it in a way that is using Maui properly, or at least the recommended data approach from the SDK standpoint, right? And so for that, in my Maui program, you'll see here, I add my services in here. And I went through, and when I converted over the Realm service that existed over to a database service, a more generic service, right? So I have an interface called iDatabase service. I then also made a Couchbase service, right? And I kind of went through and tried to keep as many of these methods as I could to minimize the amount of refactoring I have to do. And we'll go through and compare these in a few seconds. But I want to explain at least the logic of my brain behind why I did that. So I have a database service that implements a Couchbase service. And to me, this is better than having an abstract class here. It gives the same thing. It'll be a memory only one because it's a singleton. But then on top of that, it's giving me the flexibility of making a mock service and having tests run against it. So some flexibility there. This is, if I was building this for a real world application, that's exactly how I would do it. And I try to write all my demos to be as close to real world as possible. Now, if we go back to Realm, we take a look here. Realm has something called a Realm app, and this is what handles authentication. If we were to even go look at the login method, right? So we can go into here in our symbols and see the login method. You'll see here it's using the app to do login. Couchbase Lite does not have an authentication service per se. It doesn't have the ability to do authentication on the box the way that this does it, where it goes through and just it takes a username and password and tells you if it's correct or not. Now the replicator can take a username and password in, and you can go through and listen to the replicator events, but you have to listen to the replicator events to see if the password worked or not. That's not really the same feature or the same way that that works. So I made an authentication service. Like before, I made an interface called iAuthentication Service, and then I made an actual service that implements that. And so let's take a look at that first, because that's the entry point of the application, right? The application, you have to authenticate in order to get in. And that's the very first thing I then needed to replace to get this application working. So with that, I need to go through and explain a couple of things. So inside of our app here, so I'm in this template repo again. I think I have it open up over here too. Yep, let's do that because I want to go through and show you that I have some links here for this. So we're going to scroll down here and take a look at, here's the NuGet changes. And this README file is pretty good. Everything in this video is kind of explained in the README file also. So that's good news. You'll see here we're at the body review removal. We'll come back to the Android registration here in a second. You'll see here I show the services and stuff. And this is where I start talking about authentication. So what I basically say in the README is that we just handle authentication differently. So, and I explained this here. What I want to talk about is OpenID Connect. So if you're going to convert an application over, you probably want to use OpenID Connect. And this is the better way of handling security. This is support's built into Couchbase Capella for this. And what that means is you're going to use an authentication provider like Ping Federate. You can use like Auth0. Microsoft's replacement for Azure AD is called Entra. You could use that, whoever you want, right? The beauty for that is that you get a better experience from authentication. Most of these frameworks have a SDK that goes in your mobile app. And then on top of that, they have some kind of authenticator app on the phone that allows you to do two-factor authentication. It provides all kinds of cool security. But the most important thing, I believe, in the mobile application is it keeps the password out of your app in memory. And that means from a security standpoint, you don't have to worry about securing that password when somebody types it in, right? If you log in pages in your code and you're taking the password from the user, then you have to keep track of that in memory. And if your InfoSec policy says, hey, the password has to be out of memory as fast as possible, I worked at a financial institution where that was the case, it's almost impossible without using some other third-party solution for that. .NET is a garbage collected platform, right? Which means you don't know when the garbage collector is going to remove that password from memory, even if you're using characters, right, instead of strings. And don't use secure string. That's not truly secure. In fact, that's a terrible thing, and I think it's been depreciated in .NET. So what I'm getting at is the better solution for this is to use OpenID Connect, set up an identity provider, and have it handle authentication for your mobile app. And then it will go through, authenticate the user, give you back a token that you can use then to call app services as part of the sync process and only get the information that you need, guaranteeing for that user, right? Now, with that, that's a lot to set up, right? And I can't guarantee somebody that's demoing this app would have the ability to do that. So I had to make some liberties to say, there's got to be an alternative that's easier to do. And so that's what I ended up doing in the code, is took an alternative approach. So let's go look at our services. To start out with, our iAuthentication service just has a single method for login. That's all it needs to do. It's going to handle the login. It's going to take in the username, password from the screen, and then the configuration. The configuration we need to take in just like Realm did, because we need to know the endpoint URL. That's how we're going to authenticate against it, right? Let's take a look at the implementation of the authentication. Now, you'll see here, this is just a no abstract class. This isn't a static. Because in fact, we're going to use the .NET stuff to make it a singleton. It's going to get the same functionality, but it's now testable. I'm going to implement iAuthentication service, which means I need to implement this method. We're going to bring a possible nullable user in. We're going to make sure that the config is available and that we can get an endpoint here, right? We need to make sure that endpoint's reachable. And if it's not reachable, we're going to go through and throw an error that says, hey, can't get to the server, right? And this is the stuff I hate to write. Couchbase Lite, most of the time, you don't need this. You never call REST APIs. This is one time where how I'm going to solve this problem is by calling the app endpoint REST API to see whether or not the user works or not, whether or not the username and password works, right? So what I need to do is that out of the box, the configuration is set up for WebSockets, because that's how app endpoints work, is that the mobile sync is done via WebSockets. I want to use the REST API. So I'm going to convert the string that comes in from the config file from a WebSocket string over to an HTTPS. And then I just need to replace the endpoint, because I'm just going to validate the tasks endpoint, right? So I'm going to go through it and kind of do some removal, so that one, I can guarantee that the URL is reachable, but also that I can authenticate against that task endpoint. So I check the URL to check the reachability is done via the check URL, which I take the task name out because I just need to check the actual DNS, those kind of things, make sure that that URL is proper. And that's what this reachable will do. Then once I know it's reachable, then I just use the HP client and I go through and I need to base64, the username and password, right? I need to add that into the authorization header of this HTTP request. Obviously, this is going to be JSON. I want to come back. It's a REST endpoint. I go through and get the URL, and I check to make sure that it's a status code that's success. I want a 200. I don't want for any of the 400s or 500s, right? If those are bad, then I'm going to return the status code. If it's cool, and I know it's good status code, then I'm going to return the new user based on the username and password it's passed in. If not, I'm going to return a no. Now, this is my authentication method. You could absolutely do it this way. I don't recommend it from a security standpoint, because once again, you're keeping the username and password in memory too long. This is up to you to decide, but part of the conversion process, then it's to call out that we don't handle authentication the same way. And we really recommend, if you're doing enterprise level application development, to use OpenID Connect. Otherwise, you can use the REST endpoint, but then you're on the hook for handling the security of the password in memory and when to remove it from memory. So that's the authentication process, right? So once we did the authentication process, we can start to take a look at the rest of the changes that we made in the application, right? Now, we can go back to the authentication process, say right away, one of the first things that we can call out, and it's even here, is this user object. This user object comes from the Realm SDK. And if we were to go to the models folder, there's only one called item. Well, once again, because I said we don't handle authentication the same way, one of the first things I had to do is make a model called user that would basically be able to take the username and password in, and I can hold it in memory then to pass off to the replicator. And Realm keeps its username and password in memory also, right? Because it hands it off to its sync process. Once again, I just don't recommend this, but that's what they do. So to solve this problem, I made a record, because in C#, that's the modern way. If you don't need serialization and stuff to make a model in memory, it's the user record. So I went through and made a record for that user. So that's the next change I did. That was part of the authentication process. Now, once I was done with that, I need to get to the point where my item can be usable by my service. And so if I go to the models, here's my item. You can see here, we've got, it's inheriting from an iRealm object. I don't need to do that because I'm not Realm, right? But we also have a bunch of annotations, and these annotations are kind of working like an ORM or like Entity Framework, where it's kind of giving you some things of where to map that field to data-wise in the JSON, right? And then also whether or not the field's required or not, right? So these are kind of things. And then it's got a little helper here to check whether or not it's mine or not. So I had to convert this over to our Couchbase Lite. And so to do this, I'm going to start with by saying, I want to make it an observable object, so I get those cool ability to do delta changes, so that I don't have to worry about if I just change the summary field, that it goes through and animates just a summary changing. So I took out their iRealm object. I added in the observable objects. This is something that's part of the community toolkit that comes with MVVM. And as a .NET developer, I would expect somebody to understand this. This is how Maui works, right? Observables. I also bring in JSON library and the serialization library, because .NET, when it comes down to it, the Couchbase Lite SDK in .NET, it's just a document database of JSON documents. So because of that, I'm going to use serialization. It's the closest thing that Realm does. By doing that, we have a very similar experience. The first thing we're going to do is we need to do exactly what Realm was doing. In Realm, we were just saying, hey, this maps to this field, right? So these are a map to field, saying in the JSON document, we're going to have it look differently than in the JSON. So I'm going to make this to be the ID field, because I'm going to use that for my document ID. Every document in Couchbase Lite has to have an ID, and that's going to be a GUID. So I'm going to just say, hey, when this object gets created in memory during the initialization process, I'm just going to make it a new GUID. I'm going to store that as a string inside of the JSON document. Now, The owner ID, I took the underscore out. I just don't like underscores. And so that's the only real change I made in the data. Technically speaking, you wouldn't have to make that change. You could just store it and do the JSON property mapping like they did. Underscores tend to cause problems, so I just took the underscore out. As you can see here, the owner ID is going to be set to a empty string by default. And we're going to say then that the owner ID this is how it's going to be stored into JSON. I have a underscore summary field you can see here that I'm going to JSON ignore because I don't want to write this to the database. Instead, I'm going to write this version. This is a custom property, and this is part of the .NET MVVM component toolkit that allows you to do observables, right? What I want to be able to do is say anytime this string changes, to be able to not only set that property's value, but also to send the onProperty change event so that the UI can change only for this particular field. And I do that for 2 fields because those are the 2 fields showed on the screen. The Boolean for the checkbox and the summary, which is a string. Those are the 2 things that we draw. And for each one of those things, if you want to do delta changes and animate those kind of things, make it look nice, then you would have to have these as being observables in order to make that work. This is all part of .NET Maui, once again, right? I'm making no changes other than to use the community toolkit features available. And this is all part of the iNotify change, and this is all part of how MVVM works. If you don't understand iNotify change, you will want to read up about MVVM, the community toolkit, and understand .NET's kind of programmability around of state management, which is all really around the observable pattern. Now, of course, we have this is mine, which we're going to go through and JSON ignore, and we can just set that and calculate that when we bring the data in. Finally, I'm going to make a little helper method that didn't exist before for serialization. This is just going to make it easier to write into a mutable document so that I can save it to the database, which I'll show off in a few seconds here. But with this is the model changes. This is an optional thing, by the way. You don't have to provide it to JSON, but I just find this makes it a little bit cleaner when you're using your database service to write a model to the database. They have this little helper. That way you're not calling the serialization library in there and adding a bunch of bloated code inside of your database service. Also, this means that this model, if it needed custom serialization logic, you can keep that custom serialized logic inside the model itself. So it's separation of concern, which I've done in the past. So with that, let's take a look back at the data layer now, and let's go through and talk about the service and see what's changed over there. So in the realm service, let's go through and talk about various things that it can do. So one, we have CRUD, right? So we need to go through and talk about create, update, and delete. We already talked about login. Logout's pretty basic. If we go look at logout, we'll see here that it logs out the current user, disposes realm, thread for it, sets the realm thread to null. Basically just trying to go through and get rid of anything that's in memory for realm. That way the next user that logs in doesn't have in memory the previous user's information. That's what it does. And in ours, we do almost the exact same thing. So if we go take a look here, go back to our services and take a look at our Couchbase service. Since they do it in logout, we're going to do it almost the same way. So let's go find logout here. We'll see here that we kind of do the same thing. We set the user null. We don't know the subscription type, so we're going to say that no. I'll talk about previous items, why they exist, and why I clear those when I talk about deltas. We have some query listeners that I get rid of. I get rid of the replicator. I get rid of the collection, make sure that that's closed, and then I close the database, dispose it, and then set the initialization of the database to be false. So a little bit more cleanup code you can hear logout, but this truly guarantees that there's nothing in memory that the user would be using. So let's go find the, we can see here we have some subscription code. We have a subscription type, and the subscription is going to go through and handle then the subscription stuff. Now, one of the things that I found kind of weird in this, once again, as I was refactoring it, is to take a look at the edit items. To start out with, the edit items is going to take an iQueryable attribute. This is part of Realm. Okay, this is part of the Realm SDK. And what's going to be able to do then is when you do save item, it's doing the save in the view model. They have a service up here, like a separation, but here they're trying to do all the actual business logic talking to Realm. It's like, it's 2 different patterns. And to me, I didn't like this. I didn't like having the view model. The view model can do business logic, but actually talking to the database and stuff, they have the Realm service for that. Why would they do this in here when they have a service to do this, right? This is not testable now because this view model has an implementation inside of it. If you wanted to write a test case for this model with a mock, you can't because you're taking an implementation and then doing the implementation. So I made the decision once again to refactor this a little bit to make this a little bit cleaner by taking this save code out and moving this over to the database service. So if I take a look here at this is going to be the Couchbase service, I'm going to go back to our all symbols, and I'm going to go and take a look at the ability to add a task, okay? And when we add a task, we look over here, you can see here, this is how it saves the item. It opens the realm. In order to do that, make sure that the item is initialized, adds the field in for the item, then goes through it and adds a new item into the realm, and that's how it gets saved. And then you can see here, it does route back and tell somebody that it's been saved, right? We kind of almost do this, similar things. The view model is fine to handle the routing, so I'll continue to do the view model to let it handle this, but the service itself will handle the saving. So in here, we validate that the user collection exists, right? Because we need to save a document to a collection. Next thing we need to do is go ahead and find out whether or not this is an update or an insert, right? Is this a new document or are we editing an existing document, right? So if we take a look here, in this, we check whether or not this document already exists in the database. If it already exists in the database, then we just need to validate its state, make sure that get a mutable version of that document. Now remember, when you get a document out of the database, it's not mutable. Okay, by default, documents that are retrieved from the database are not mutable. But in order to make changes, you have to convert it to a mutable document. So you'll see here, I make a new document by taking the existing document and convert it to a mutable document. Once it's mutable, I can just set any property on it I want. This is like mapping code, right? So you can go through and say, well, I'm only really changing one field. Inside of there, the only field you can change is the summary field in the UI, right? And if you watched the previous video to see that, you know that. And I'm just going to go back in here. If I were to go here and edit this field, the only thing you could do inside the app is edit the field. Since it's only one field, I shouldn't serialize the entire document, the object, to write it through because there's a bunch of fields I didn't change, right? That doesn't make sense from an efficiency, and it also could add some regression. So somehow the data gets mungled up. And so because the UI only changes one field, and they even in their code only change one field here, the summary, I made the decision that to do this, we can just use key value pair editing of the mutable document to update that one field versus JSON serialization. So I edit that one field, just like Mongo does, and then I go through and save that to the collection. That will then cause a sync once the replicator is available. Now that's only if it's an edit. If it's an insert, then we can use serialization because we need all the fields, right? So then this is pretty easy. We just go to the item, and earlier I talked about that toJSON serialize method that goes through that helper. Then I make a new mutable document. I take the ID and I pass that in as the document ID. And then I pass in the JSON string for the actual document itself. And I just save that document to the collection, and that's it. So that's how I handle the ability to add or edit documents into the database on that particular view model. Now you'll notice that there in the application, there is the ability to delete a document, right? And that is available inside of the code here of the Realm application. They do allow the delete, and that's in the items over here. Once again, they have the database code kind of over here. You'll see here that they write in the view model. This is in the items view model. They do the right to delete over here. They go through and check the ownership of the document. So they go through, this is a security check, right? And then if the security check passes, then they allow the removal of the document from the realm. We kind of do the same thing here. We do a validate state. The validate state is that check, right? To check to see whether or not they have the permissions to do that. And if they do, I go through and then find the document, make sure that the document already exists. You can't delete a document unless it exists in the database. If it doesn't exist in the database, then I just delete it. So very similar code here. So over here, I changed the method name from check item ownership more to validate state because it's a generic validation then. Really just a naming convention thing for me. Here, let's see here. And that handles delete then, right? So we've got that. Let's talk about the initialization process next, because that seems to be the next thing in the file. And to do that, we can go back to the Realm service, right? In the Realm service, we have an init function here that goes through and initializes the entire function or the entire realm and stuff, right? I don't 100% agree with this, the way it's doing it, because it's the init. To me, there's two phases of initialization. Okay, the first initialization is just getting config file reading in. And that needs to be regardless, right? Because we need to call the REST API to guarantee that we know that the user can get into the application. So, but that's the only thing. We shouldn't be opening databases or anything like that because we can't guarantee that the username and password are the proper username and password to log into the application, Realm handles this internally as part of their Realm creation process, right? The authentication stuff. So because of that, I needed to go through and make two different init functions. I need to keep this concept of the init function of reading in the config file and getting that into memory so I can then do authentication. And then I need a separate init function for doing the database initialization itself. So the first init function, as you can see here, just sets some logging so I can go through and see what's going on. And I give you a link to the logging in the docs. Then I go through and I make a file stream just like they do. I go read in the configuration file. Instead of the Atlas, I read in the Capella config file. And I just serialize that to an object. So that way I can use it in authentication. Now, once the user authenticates in and everything's cool, that's when I go through and initialize the database, which is a little bit more complicated of a process. If you're wondering where I do that, that's a good question. Let's go through and take a look at that. So if we look at the login view model, you'll see here, it's going to go through and say, I have a database service here. It's going to go through and knit the actual database service. That's going to read in the database configuration, right? And it's going to check if we have the current user authenticated in. If it is, we're going to go to the main page. Otherwise, we're just going to keep this page up. We need to go through the login process here. We validate that the username and password are proper data, that there's something in the field, right? And then we're going to do the login process. The do login process, this is, by the way, very similar to how the Realm app works. So if we go look at its login, you'll see that most of these methods exist, like do login exists. It's the same name. So, you know, from that standpoint, I didn't have to change the name of the functions. I just changed what they call, right? I do the database service login. I see whether or not it's busy or not, right? And then I make a decision to go main page, right? And go to main page, you'll see here starts the shell. So that's the gate that's basically going through and saying, hey, look, if the user is a good user, then we'll change the main page to be shell. Shell can handle all the navigation, all those kind of things. And that guarantees that you can't hit the back button shell and get to the login page. Instead, you have to use that log out button. It's just a better way, less regression of handling the navigation of the pages. So then we'd have to say, well, okay, what does app shell do, right? So let's go back to app shell then and see here that app shell is then going to go through, register our component and get that all set up and good to go. So then we can go look at items, right? So items view model, if we take a look, the route that's going to happen, app shell by default is going to load in the items page. Okay. See, that's the very first page it's going to load. So that means we have to look at items view model and then items page if we're going to follow the flow of this application, right? So here's items page. We go through and do a binding to the view model. We inject in the view model. We do that because this is how usually you build a Maui application, right? And we register all the view models inside the Maui program again. And that's usually how you do this. You make those transitant, you know, so these will be lazy loading, basically saying, look, when you need it, here's the login page, here's a view model. And this is how I've done, even back in Xamarin forums, I used to do it this way. This seems to be the pattern. Obviously, the builder is provided by Maui. This is just part of the builder process of building a Maui application. So let's go through and take a look at the items view model then. We know that that's coming to memory. We'll see here that we're going to go through on appearing, make sure that the user is cool. If the user is cool, we're going to go through and set up our live query for that. And if not, we're going to go through and throw in an exception because the user should be logged in, right? This should never happen, basically, right? But we need to guarantee from a security standpoint that we're good to go there. So to see where the database is initialized, though, which was the original thing I was going to talk about, was we need to go back to the service and take a look at that real quick. So in the Couchbase service, the Couchbase service still passes the authentication process over to Authenticate service because that's what Realm did. If we take a look at Realm's service here, it has the login function in it. So if we go take a look at the login, it calls the app login, and so our authentication service is going to emulate this app login, right? And you'll see here, this is what sets up the Realm and sets up the subscription. Well, then if this is going to do that in the login for Realm, right, we should probably do that in our Couchbase service also. So the try to keep this going, you'll see here that in our login, we're going to first make sure we have a config. We're going to call the authentication service, which is our version of the app. And then we're going to go through, make sure that the user is there. And if the user is cool, because of the fact that we authenticated in, then we initialize the database. And that's what's going to call the initialize of the database process, making sure that that user is there. And so then if we go back to take a look at that, we can walk through the database initialization process. So the first thing we need to do is make sure that the database hasn't previously been initialized. So this is just a guarantee against regression. If somehow somebody instantly calls this method twice, we don't want to go through and set up everything twice, right? So this is just a little regression check. We validate, even though we did before, we can't guarantee where somebody's calling this, right? So we're gonna validate the current user is not null and the app config is not null. I know that we do this inside the login function, but since this is a public function, can't guarantee somebody accidentally doesn't call this in the future from somewhere else. So I'm trying to keep a little bit of regression at check here. We go through and get the calculated username. Now we need the calculated username to make the database name. We're gonna make a unique database for each logged in user. And so by doing that, this could be supported like on an Android tablet that has multiple users using that. And we'll keep each database separate for each user, separating the security of that database from each user. We're gonna go through and do a database config. The database config just takes, and where do I wanna save this database, right? We're gonna go through then make the database based on the configuration, database name. Database name again is calculated based on the current logged in user. We then need to go through and get a collection to store the documents, right? Now, here's the cool thing about the database create collection that most people don't know. If the collection doesn't exist, it will create a collection and pass that collection back to you. If the collection already exists, it will just pass back the collection to you. So there's no need to write in your code to check if a collection exists, and if it exists, creates, and if it doesn't, then go through and just go get the collection. Instead, just use create collection, and you'll get either a new collection with that information, or if it already exists, it'll send back the existing collection, which is a nice, less code. Since we are using query, we're gonna go through and create a very simple index. The index is gonna be on the owner ID field. And so this is just a value index, the most core basic value index you can create. Now, I cache queries, and this is something that is not required, but a quality of life improvement. You're probably gonna say, well, wait, what? So in Couchbase Lite, how we query the database is using SQL++. And when we generate a query, we convert that over into like, I wouldn't say bytecode, but it's in a format that allows the Fleece engine, which kind of queries the database, to be able to query items, okay? And so because of that, every single time you make a query, it compiles it down into that Fleece format, right? And that's the simple way. It's a little bit more complicated than that, but let's just gonna try to keep this easy for people new to the SDK to understand. Well, that little switch in the application is constantly changing the query. So if we go back and take a look at this, every single time I click this, it's changing the query. That's a lot of creation of new queries, right? That's actually inefficient from a .NET standpoint of constantly making those in memory. So what I do is I say, well, I know there's actually two queries going on here. There's a query for just my task and a query for all tasks. So because of that, I just make two queries. I'm gonna cache those in memory. I'm gonna cache a query called query all tasks. They're just gonna go get all the items from the database using a SQL++ query. Very simple. Select star from data.task as item. And then I'm gonna make my query tasks. And that's gonna be, take that existing query I already created here and then append onto it a where clause that just checks the owner ID to make sure that it's the current username. And that's how we're gonna check to see whether or not they're my tasks. So in the end, I'm caching for each authenticated process, right? So when you log into the application, you init the database, I'm going to cache two different queries, one for all tasks and one for my tasks. By doing that, when you click that little switch again, you're not constantly making these new. It's going to save you a bunch of memory. And honestly, this is it could performance hinder on Android if you have a low amount of memory on the device and a slow disk. Caching your queries could actually gain you net performance. The next thing we want to do is once we set up our cache queries, we're going to go through and create the replicator. The replicator is what syncs between your mobile app and Capella App Services. So with that, we need an endpoint. We're going to get that endpoint. We did that earlier from the app config. The app config stores that. We get that from serialization. We covered that earlier from this Capella config file, right? Inside of here, there's a Capella endpoint, and that's what calls in the configuration of that, right? And so that we're going to use that URL to actually talk to Capella App Services, that particular endpoint. This needs to be in a URI, and then the URL we pass to the URL endpoint. And the URL endpoint then knows, okay, that's where I go through to talk to App Services. We need a configuration, okay? In the configuration, we're gonna set it to continuous. Continuous simply means that the replicator will continue to run anytime updates as long as the internet's available, right? As long as it has a connection, it's gonna go through and continue to replicate over and over again as it needs to. Also, that means that if you do lose internet and you then get it back, it will automatically go through and handle the sync process. You don't have to do any reachable code whatsoever. the SDK will handle that for you, which is really kind of nice. It's set it and forget it. In the world of continuous, you're going to say, hey, I just want to replicate whenever I can, and it will handle that for you. You can do a one-time replication by just sending continuous to false, if that's what you're looking for in your application. I recommend this. It's up to you to decide based on your business rules how you want to set up the replicator. I'm also going to do push and pull. Push and pull simply means that when I have documents on the device, I'm going to push those out to Capella App Services. And then I'm going to also pull documents from Capella App Services down to the mobile database. So we're doing two-way syncing. Both we're sending information and we're getting information. If this was an IoT device, for example, you may only want to push documents, right? You're going to say, hey, I'm getting information from a sensor. I'm going to then just only push documents. The IoT device has no ability to modify existing documents. It's just sensor data that it's getting, right? That's where you'd want to use just push maybe. And pull may be used for like a dashboard application. Maybe you have an application where the users can't ever modify any data. You're just reading it. And I've written quite a few of those applications in my time for leaderships at companies, et cetera, right? In those dashboard style of applications where you're not really modifying data, well then maybe pull is the configuration you only need. Now finally, we need to authenticate somehow. And in this application, like I said, I'm going to use the REST endpoint. And because I'm using the REST endpoint to validate the username and password, I can just use basic authenticator where I'm passing in the username and password. There are other methods for authentication, right? I covered that earlier with OpenID Connect, and that's my recommended approach. But for this particular implementation, to keep it simple, we're just going to use the basic authenticator. Now, next we need to go through is tell it what are we going to sync? What collections inside of Capella and app services do we want to sync? Well, that's going to be based on the collections that we have. And right now we only have one in our application, right? But if you have multiple collections and you have that configured in the app endpoint, right? Because this is a two-way thing. You not only have to have it configured in your app, but you have to have that same set of collections configured in your app endpoint. Otherwise you can't sync them, right? So I know that when we set up ours, we only set up that single task collection. That's the only one we have set. So I'm going to add to a collection config that task collection to it. Now, I don't have anything else in this collection configuration. There is other things you could do in a collection configuration. You could do things like filter channels. So you can say, hey, on top of this, I want to limit the documents coming from certain channels. You could do that inside of the collection configuration. You can even filter documents down by their document ID, saying, look, I only want these 3 documents, right? It's up to you. You can go read the docs on this to find out more about the collection configuration. But for me, I can just use a blank collection configuration for this simple application. That's going to work. So I'm going to add to the replicator config the task collection with a blank configuration that's just basically been newed up. Finally, I have a replicator config done. I'm going to go through and make a replicator based on that configuration right here, right? And then before I start the replicator, I want to check the status to see what's going on. And I'm just going to write these to the console if there's an error so that I can go see what's going on, right? So I'm going to just go through and see, hey, if there's an error in the replicator, just write it off. You can write this to a log file. You can even have a UI thing come up to say, hey, look, something happened with the replicator. They didn't have that in the .NET application. So because it didn't have that in the .NET application, I just chose to write it to the console and let you kind of pick up the error from there. Finally, once we have our change listener set up for the replicator status, I start the replicator. And then, of course, we want to make sure that we know that the database is now initialized. And this is that check up here, just make sure that doesn't happen twice. And once again, this is just to handle a little bit of regression in case somebody were in the future would accidentally call this twice. More of my preference thing than anything else. Now that the replicator starts, the application can work. So this would allow the database then, once you log in, to go through and function properly. So that's that. So we have a very simple helper task, and this is the same code from theirs. I moved it out of the model into here to just say, is this my task? And it's nothing more than that. We already talked about login. We already talked about log out. Pause and resume. So pause and resume are based on 2 switches inside the application. If we take a look here, that is the little, I've talked about this in the previous video, this little Wi-Fi. And if we take a look at theirs, it's almost the same thing. If we go back to their symbols, they should have a pause and remove, but it's not in the service, it's in the view model. So in the view model, if we go through here, they should have a pause and resume in here. Change connection status is how they handle it here. The stop or start the replicator. I took this one single method out and made a pause and resume, and I handle it inside of the service instead. So there's a little bit of refactoring the code out here. So in the items view model now, if we were to go and look at our items view model, let's go through here, items view model, and take a look at theirs. Let's take a look here. Toggle is complete. Not sure. Oh, here we go. Now we can see this, but why are we? It's where we're not getting the symbols. That's where we're not getting all the method symbols. It must be because of the inheriting from the view model here. That's weird. I guess let's go through and just take a look at it together then because of that. Not sure why the symbols is not showing up here and there. I can't tell if that's or not. Right here, change connection status, you'll see here. Change connection status calls the Couchbase service instead, pause or resume. And it's really almost the same thing as they call the realm sync session, right? Since we are saying our service is going to own this stuff, that's the only difference. We call it the Couchbase service instead, and that will handle both the sync of pause and resume. And so that's why those functions exist inside of the Couchbase service. So let's go back up to here. Where were we? We were after pause and resume. So we've already done add. We've talked about delete. We've talked about initialization, is task, login, resume and stuff. We're pretty much to the point where we want to talk about live query a little bit here. So the final part of this application is like, how do we get items onto the screen? If we take a look here when the application starts up, let's go find our iOS application. We get a list of items here, right? Based on if you have this switch set, you get my task or you get everybody's tasks. Well, how we handle this in Couchbase is something called a live query. And this is a, let me go into the docs here to kind of show you. There's a great set of documentation that explains this in great detail for live queries. It's, you add a change listener. And so anytime the query, any document the query changes, it's going to automatically send back all the results of that query again. That's how live query works. And so with that, it's not 100% of how MongoDB system works, right? In MongoDB, you have a subscription, and that subscription then will change based on your link query. And you'll see here, they set up the subscription here saying, what kind of subscription do I have? Do I have a subscription of all the documents? And there they come objects, all objects, or just mine. And that's kind of how they handle the little switch there, as they kind of go through and change the flexible query, it's called, right? Well, in here we have something called a live query, and we're going to do the same trick. We're going to keep their subscription type. So if you take a look here, that enum is the same enum, and it's defined inside of this file. It's actually defined inside of the realm service, I want to say. Yeah, they'll see here that here's a subscription type, right? It's enum. Kept that because it's a conversion, right? So that's kind of logically makes sense, right? If we're going to say, here's the subscription type, here's our query, right? This is going to go through and set up our query based on the subscription type. And they're using link in theirs, right? So you can see here, this is a link query. I'm going to do something very similar, but I'm going to use live query. I'm going to pass in the subscription type just to say, hey, look, I don't know which version of the query we want. Do we want all items or just your items? And then we're going to take a callback, and the callback is going to be something called iResult change. Behind the scenes, if you're not using the link SDK that comes with Realm, this is really what's going on behind the scenes, is that they have a Delta thing that calculates the Delta changes. And so I'm going to manually kind of do that inside of our code, which I'll show you in a second. But either way, I'm going to take back an iResult change instead of items in a callback. And that way the view model can get updated. And since these are observables, we talked about that earlier, we then see the changes only to that. So I need to just figure out which subscription type is this, right? I'm going to either make it the query based on the subscription type, either the my tasks or all tasks. And we talked about that earlier when we initialized the database, we cache those queries, right? Now, if we already had a change listener up for our query, that's how live query works, we're gonna remove the existing one. So the minute that you hit the switch, we're gonna swap between these queries. Well, then the previous change listener, we don't need anymore because we're changing out the query. So we wanna definitely dump the previous change listener. Then we just add a new change listener, right? So this is how live query works. You're gonna get a token back, and that way you can remove the token when you're done with the listener. And that is something you should do. This is a disposable thing where this is disposable. So in the query, I'm gonna say, hey, add a change listener. I'm gonna get the change back of that. And now this is where I'm gonna calculate the deltas, okay? Now to calculate the deltas, we just have to understand how I did this. So inside of here in data, I have a request change file, and I need to go through it and review that with you so that we can understand this. And this is how Realm's SDK works behind the scenes. Kind of looked at their code and made a decision, tried to follow as close to their patterns of how they handle change as possible. I have a interface called iResultChange that is a generic. And we have two different ways. We either have an initial set of data that's going to come in, and that's going to just give a list of generics, right? And this is going to be items in our app, but you can reuse this to say whatever you want, right? And so this is just going to give us that list of initial results. Or if this is a delta set of changes, then we're going to give three things back. We're going to give the insertions, the deletions, and the changes, right? And by doing that, you can then update your observable collection to say which one of these I need to add to the list because they haven't existed before, which ones that I need to remove from the list because they no longer exist, and then which one of those have maybe a field that's changed, like the summary or the is completed. And this is what's given us that cool animation, is the fact that we're going to give these delta backs instead of the full list of collections, just like the existing Realm app worked. So let's go back to our Couchbase service now that I kind of explained that a little bit, and we'll take a look at the Couchbase service to see how that's implemented. So we get our change, and then we set our initial list. Okay, so we need to calculate whether or not this is an initial load or if it's a delta change, right? And the way we do that is we're going to store the previous query of items in another dictionary. Okay, so if we scroll at the top here, we'll see here we're keeping a dictionary of the keys of the item. So the string will be the document ID, and then this will be the item itself. By keeping this and setting it to blank by default, we'll know whether or not this has been the initial load or if we need to calculate the changes, the deltas. And we can use this based on the previous results to calculate those deltas. And that's a kind of a nice thing that we could do with this little pattern. So if we go back here to say, okay, then we know that we're going to check the previous list that we kept. If it's 0, we know that this is an initial load, and we'll make a new one of those. We're also going to new up the deltas just in case it's a delta. We then get a map of the current items. We need to do this to track the deletes. Okay. We're going to trim out the items. And you can see here, we're going to use that to say, hey, look, here's the previous keys. And we'll use this for that deletes, like I said. We're going to loop through each one of the change results. And we're going to go through and convert that using serialization, right? Because remember, we're going to get the item from the result set back, the change. And remember, we have that toJSON helper function that we're just going to go through and give us the ability to serialize this item. This is going to come back as a JSON string, and then we're going to serialize this back to an item based on that JSON string. We're going to validate that the item's not null, that the serialization worked. If it doesn't, we're just going to continue because we don't know why the serialization didn't work. Next, we're going to set that calculated field to see whether or not this is my document or not. And we can just check that by saying, is this owner ID equal to the existing user? And by doing that, this is a calculated field, it can be popped in. Now we're going to go through and figure out if it's an initial load. We're going to go through and add it to the initial list. Else, we're going to calculate the delta. We're going to see whether or not the previous list already has this item in it. We can just do that by saying, hey, I'll try to get this item in the list. If it doesn't exist, then we know that we can even pop it into here as a change, or we can go through and say that it's an insertion, right? Because we're going to check here to see if they're equal. If they're not equal, then we know that this has been changed. If they are equal, then no change has been made to it, which means we don't have to do anything with it, right? We're just going to keep it because it's not a change. Then finally, we need to go through and remove the item from the previous items, right? Because we have it in a new list that we're keeping track of that. Now, once we went through and looped through all these items, right? We've calculated, is it an initial, or we calculate, does it already exist in the list? If it already exists in the list, has it changed? If it hasn't changed, let's make an update. If it, otherwise, we know that if it wasn't in the list, then it is an insertion. We now need to go through and say if it's not the initial list, then we need to get rid of the deletions. By doing that, all we have to do is check the previous list to see what's left over. Because each time we're looping through the changes, we remove the item when we're done from the previous list. Well, then obviously, if we removed all the ones from the change, anything left over was never given to us from the change, which means it's a deletion. So we just loop through the previous items, add that to the deletions list, and at this point in time, we can clear the previous list because we've handled our updates, our inserts, and our deletions as part of our delta. We just remove those, and then we take the current map items and we make the new previous item list by adding those new items into the previous item list after we clear it. This will become our next set for delta changes if this runs again, if the query updates, right? And finally, all we have to do is say, which one are we going to send to the callback? Are we going to send the initial results, or are we going to send the updated version? And then finally, we want to cache the subscription type, so we know about that. And so this allows, if you navigate back and forth, to understand that. So inside of the service, we're going to just cache our current subscription type to whatever type they sent in. And that's pretty much it, folks. That is the calculation of deltas. Now, if we look at the items view model, we could take a look at how do we then render that. Well, inside of here, you'll see here that this is all handled via these queryable, right? So if we take a look here, inside of Realm is making a queryable item, right? You see iQueryable of items because they're using link. In ours, we're going to do that a little bit different. We're going to use an observable collection because we are serializing documents back, right? So we have an observable property, it's an observable collection, and then each item inherits from the observable object, which is going to give us our observable pattern, right? That's in .NET, very cool, part of the Maui MVVM toolkit. So within that, we then just need to take a look at our, once we go through and initialize, we should go through and get on appearing here, we set our live query, right? And our live query is going to take in, like I said, a callback, which is called update items. So then all we have to do is take a look at the update items function, because that's the callback that we're going to do. And right here, we say, here's our callback. So our callback, as we said earlier, is going to take an iResults change of items back, right? We're going to invoke this in the main thread because we want this to be updating the UI, right? And so in here, we're going to make that decision. Hey, look, we need to invoke this in the main thread. Realm does this, but they keep a separate pointer for the main thread, and they handle that internally then as part of their stuff. And if you remember back to the Realm service, they usually keep a track for this right here, the Realm main thread, right? So we're just going to use Maui's built-in one because the only time we really need this is when we update the UI. It updates the UI for itself as part of that iQueryable. So that's why they need the pointer to it. Here, since we don't use that iQueryable pattern, we're just going to use it with the main thread here. We're going to loop through the results items and see what kind of thing it is. We're going to say, hey, where this item that we're passing in is of type initial results, then we know that. Well, then we're going to take our existing observables, clear it out, right? Because they shouldn't be anything in there to begin with, but just in case there is. Then we're going to just loop through each one, adding the item in, and then breaking when we're done. And that will get us an initial load of the observable collection. And that should then animate out those items being added to the list. Now, if this is a delta change, it would be here. It'd be the updated results, right? Well, then we need to go through and talk about the deltas. First thing we're going to do is we're going to insert any new items to the list, right? Because those are insertions. And then we're going to go through remove the previous items, right? If there's anything deleted, we'll remove those items from the list. Then finally, for anything that's changed, we're going to go find that item, right? We're going to go through and say, hey, look, I'm going to go find that item from the list. If I don't find the item from the list, I'm just going to continue. That's kind of weird, right? It should be an update, so it should be in there. I'm going to go get the index of it, and then I'm going to swap out the item in the list for the new item by taking the index and swapping it out. Then I just need to make sure that this onProperty change function calls for the items list, right? Because we know for a fact that we've made a change to it. And that's going to guarantee that the observable collection runs, and then the list goes through and updates. And folks, that's it. That is all it took to get the live query up and running with delta changes. So it's a little bit of code that you have to write yourself, but the advantage is that you're getting those super cool fluid animations. So with that, that is my review of, for the most part, of this code that was changed, right? So we have this new couple changes that we made inside the items view model in order to handle the changes that we did there, right? We went through and showed off the login view model, so changes there. We showed the Couchbase service, which is pretty much where most of the stuff happened, right? We replaced the Realm service out with this Couchbase service. We are doing injection, so a dependency injection in through the constructors, which is part of the solid pattern and usually recommended in the .NET applications. And I showed you all the technical that we took before to update it to .NET 8. I want to appreciate you for sticking around for this entire video, and I look forward to seeing you in the next one.